Okay, so today I'm covering how to identify the GCF, which is the greatest common factor. One of the things that we're doing this week, actually, the only thing we're doing this week is factoring. And one of the steps is to factor out the greatest common factor. So you have to kind of know what it is first, so you know how to factor it out and then continue with your factoring. So let's start with the word factor. A factor is a number or quantity that when multiplied with another produces a given number or expression. Basically, numbers that are multiplied together are called factors, and the resulting answer is called the product. We've seen product being used for multiplication, and that's coming because you multiply and it produces a new number. So the numbers that you multiply together to get this other number are called factors of the larger number. We've actually used factors before. Back in week 1, we were doing prime factorization to simplify fractions. And when we're doing that, we were looking at the same concept, but with a slightly different definition. So numbers that divided evenly into another number are called factors of that number. These are equivalent. It's just when the whole purpose was to reduce, you were looking for factors that you could divide out. So that's why we looked at that definition. When we're looking at the greatest common factor, we are basically looking for things that are multiplied. We're still going to be dividing these out, but we're going to rewrite it as multiplication. So that's why we're looking at this from the multiplication standpoint. So our focus today is just to identify the greatest common factor. So it's a factor, so it divides evenly into what we're looking for. It also means that we're multiplying it by another number to get the larger number. Common means we've got multiple terms we're looking at, and this is a factor of everything, all of the terms. And then greatest, it's the largest factor. So it's the biggest thing that we can divide out of all of the terms we have. So that's what comes from the greatest common factor. It's usually smaller than our terms, though it could be equal to one of the terms. So we're going to start by just looking at numbers and finding the greatest common factor out of a set of numbers so that you can see, get practice with numbers, because the process with numbers is different than the process with variables. So there are two methods. The first method is just to list every number that divides evenly into the numbers you have. So you're listing all of the divisors. And then the biggest one that they have in common is the greatest common factor. So that method is good if you have smaller numbers, because there's not a lot of them that you need to write down. And you have practice with this, because writing the divisors is basically, actually, you haven't practiced this yet. You will later this week. I'm thinking backwards. Writing divisors is something we're going to do later on this week when we're factoring trinomials. So you'll get practice this week with this concept. The second method is to use prime factorization. So that you have seen, because we use that to reduce fractions. And it's also a method that you can use to find a common denominator when we're trying to get common denominators out of fractions. So when you're trying to find the greatest common factor, when you're doing the prime factorization method, you basically do the prime factorization for each number that you have. So you're doing a factor tree. And then you select everything that's written down. And if they have things in common, you look at the exponents, basically how many that exist, and then you take the smallest exponent. It's kind of hard to explain in words. It kind of makes more sense when you're actually looking at it demonstrated. So we're going to start with finding the greatest common factor between two numbers, 30 and 42. And we're going to use both methods here. So we're going to use the divisors method and then the prime factorization method. And there are multiple ways that you can organize your divisors method. So let's start with the number 30. So the divisor's method means you're writing down all of the numbers that divide evenly into that number. So I usually start with a 1. 30 divided by 1 gives me 30. So that gives me two numbers because I know that 30 also divides into 30. And then I try 2. 30 divided by 2 is 15. And you kind of go through this process until, if you get decimals, it doesn't divide evenly. So you keep going until you start kind of coming back up the other side of my list. So I can do 3. 30 divided by 3 is 10. 4 does not go into 30. 5, 30 divided by 5 is 6. And then the next number would be 6, but that's already on the list. So I can stop. So we've got 8 numbers that divide evenly into 30. So those are all 8 numbers here are factors of 30. Then you do the same thing with 42. So that's 1 and 42, because 42 divided by 1 is 42. 42 divided by 2 is 21. 42 divided by 3, and you have to get your calculator out when you're doing this process. That comes out to 14. 42 does not divide by 4. It does not divide by 5. I don't believe it divides by 6. Oh, it does. Yes, right. 6 times 7. Duh, I should have known that. And then the next one would be 7, but that's already on the list, so I'm done. So there's also 8 numbers, 8 factors of 42. So you can see that they have several that are in common. So they both have 1 on the list. They both have 2. They both have 3. And they both have 6. And those are the only ones that they have common. The greatest common factor is the largest out of those that they have in common. So that would be 6. So that's the divisor method, is you take your numbers, you write down every number that divides into it evenly, and then you look for the biggest one that they have in common. The showing work like this, so I'm going to just say, showing work like this is used to factor trinomials, which is something you'll do later in the week. So writing numbers in pairings like this is going to help you when you're factoring trinomials, because you're going to be looking for 2 numbers that multiply together to get you to the bigger number. So that's why I've set it up this way, is because this is a method that is used not necessarily to find the greatest common factor, but to just figure out what numbers multiply to a larger number. And later, you're going to be looking for a specific combination that adds to something else. So having them in pairs like this is very helpful. Now, the prime factorization method starts by making a factor tree. So you start with like one of your numbers, 30, and then you say, okay, what 2 numbers multiply to 30? So 5 times 6. 5 is a prime number, so you circle it. Then you split up 6. 6 is 2 times 3, and those are prime numbers, so you circle them. And once you get down to all the primes, you do the same thing with the other ones, so 42. So that's 6 times 7. 7's a prime number, and then 6 is 2 times 3. So for this method to find the greatest common factor, I'm going to rewrite the prime factorization. So 30 is 2 times 3 times 5. And 42 is 2 times 3 times 7. And then you're going to be looking at what's in common. And as I'm reading this, my explanation definitely was very confusing, that I tried to explain this in words. But we're looking at, they've got 2 in common. and they've got a 3 in common there. So your GCF comes from those things that they have in common, the factors that they have in common. And it's going to be 2 times 3, which comes out to 6. So since they both don't share a 5 or a 7, you can't divide out a 5 or divide out a 7. So it's not in common because we're looking for the greatest common factor. So you're looking for, when you're looking at the prime factorization method, you're looking for the numbers that are in common, and then you're building up to the greatest by doing the multiplication. So let's do another pair of numbers. We'll do it both ways, and then we can kind of see which way you prefer. For me, it kind of depends. Sometimes I don't show work at all. I just try to do it mentally. If you know your multiplication and division really well, you can do it mentally. So using the divisor method. So I've got 54. So that is 1 times 54. I know that it's divisible by 2 because it's even. I don't. 2 times 27. I have to use my calculator for that. 54 divided by 3. So that's 3 times 18. If I divide by 4. Nope. 54 doesn't divide by 5, divide by 6. 6 times 9. So then I try dividing by 7. That's a decimal. I try divide by 8. That's a decimal. And then I get to dividing by 9, and that's already on my list. So I can stop checking. And then 78. So that's 1 times 78. Divided by 2 gives me 39. Divided by 3 gives me 26. My phone.
I didn't catch that. Can you rephrase it?
My phone thinks that I'm talking to it. Divided by 4 gave me a decimal. Divided by 5 gives a decimal. Divided by 6 gives 13. Let's try divided by 7, decimal. Divided by 8, decimal. Divided by 9, decimal. 10, decimal. 11, decimal. 12, decimal, and then we're back up to 13. So you kind of have to sit there on your calculator writing down and keep trying division until you've got all of your numbers, and then you're looking for the biggest one that they have in common, which once again looks like it's going to be 6. It's the biggest number that they have in common on the lists here. So our GCF here is also going to be 6. And you know, I could, the previous example between 30 and 42, I can mentally say to myself, I know that 6 divides evenly into both of those, and that's the biggest number that divides into those. I can do that in my head because I know my multiplication tables and I know the numbers that multiply to 30 and 42. I may know the numbers that go into 54, but I'm not very familiar with the numbers that go into 78. So it's a little bit harder for me to do that mentally. And I would want to show this work to kind of figure it out and make sure that I do have the largest that divides into it. So it kind of depends on where your mental skills are, because if you can do it mentally, you don't even need to show any work, but sometimes you can't do it mentally. So now let's use prime factorization to show, you know, what you would do there. So we'll start with 54, which is 9 times 6. 9 is 3 times 3. And then 6 is 2 times 3. And then 78, which, well, I don't know off the top of my head, so I just grab it that from my list that I already made. You know, normally if it's an even number, I say, well, I can divide it by 2, and then I go from there. I know that 39 is 3 times 13. And I just know that because I play cards a lot. And a deck of cards, everything's divided by 13s. So that's that prime factorization. So with 54, we've got 1, 2, 3 threes, and we've got a 2. So it's 2 and then 3 to the third. And then with 78, we've got 2 times 3 times 13. So they've got a 2 in common. And they both have threes, but one of them has 3 of them. The other one has only 1 of them. So this is where I was saying you take the smallest exponent, because the only thing they have in common is 1 of them. And so then we get 2 times 3, and then that gives us 6 as our greatest common factor. Another way to do this would be to, kind of color in or highlight what they have in common. See if I can get I don't know what color is this. Okay, so it's showing up really dark, but like I can say, okay, they both have a 3 and they both have a 2. So I can highlight those. And then that's all they have in common. So my GCF must be 2 times 3. So you could highlight or kind of color in what they have in common, and you have to match up 1 and 1 to 1. And then you multiply those together to get your greatest common factor. So you've got 2 methods here. You've got 3 methods, because you can just use your multiplication division and know what's the biggest number that divides into these. So it's not always the biggest number that you might not think of the biggest number. You've got your method to use the divisors to write down every possible number that multiplies to these and then find the biggest one. Or you can do prime factorization and then look for, well, what do they have in common? And then you multiply those together to get your greatest common factor. So which method, let's do either the divisors or the prime factorization method. So out of the 2 that are on the screen, which one do you prefer? Because I will use that method going forward. Or if you don't have a preference, I can alternate or kind of do based off of which one I would do. I'll take that as you don't have a preference. Well, prime factorization is easier, but harder to see. Divisor, you see all of the numbers. It's a tough one. Yeah. So maybe what I'll do is I'll just, go from what I do. And then, I can back it up with another one. So like here, we've got 3 numbers. So we're looking for a number that I can divide into all 3 of these. 42, 30, and 60. So this one I would probably do mentally. And just knowing that already 6 is the largest that goes into 42 and 30, because we already did those. And now I'm adding 60 and 6 goes into 60. I'm like, okay, well, 6 is the biggest number that I can think of here. And just mentally, I can think to myself, oh, well, it's gotta be 60. So mentally, or it's gotta be 6, not 60, because that's 6 is the biggest number that divides into all 3 of those. But let's practice with the divisor method. So I kind of wish now that I had picked different numbers, because we've already done these before. So 1 times 42, 2 times 21, I think it was 3 times 14. And then it was 6 times 7. Then 30, we've got 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And then 60. So 1 times 60 gives you 60. 2 times 30. 60 divided by 3 is 20. 60 divided by 4 is 15. 60 divided by 5 is 12. 60 divided by 6 is 10. Does it divide by 7? I don't believe it divides by 8. No, divides by 9. And then we're back to 10. So 60 has a lot more factors than the other numbers here, 42 and 30. But we're still looking for the largest one so that they have in common. Now, the downside of the divisor method like this is sometimes you've got so many numbers written down, it's kind of hard to see it. Sometimes it helps to kind of like, you know, start from the biggest one and then see if the other two numbers have that number in common. Like I between 42 and 30, the 6 is the biggest one that they have in common. And so you could just say, you can even look at the smaller ones and then go from there. But they both have 6 in common, and then just make sure that's on your third number. Or you can go at the biggest one and say, okay, well, if I start with the biggest number, 30 and 60 both have 15. Does 42 have 15 on the list? And if it doesn't, then you go to the next one in common. Like 30 and 10 both have 10, but 10 is not on the list for 42. So then you keep going through. So the divisor method here also gives us 6. But I would say for a problem like this, you could just, as long as you know your multiplication and division, you can do it mentally much faster than actually writing down all of your divisors or going through the prime factorization. And I usually only write them down or do the prime factorization when they're really large numbers and I can't do it mentally. So knowing your multiplication tables and your division mentally can really speed things up for you, because then you just know instantly. It's like you have memorized what numbers go into something, and then you have a lot less work to do. So that's basically how you do it with numbers, as you're just like asking yourself, what are the biggest numbers I can divide out? And then that's your GCF. And if you can't do it mentally, you try one of these methods. It's different when we're looking at variables, but honestly, it's easier, way easier. So when you have expressions that have variables, you look for the variables they have in common, and then the GCF has the smallest exponent. So if they all have exponents on it, the one that's smallest is used in the GCF. And this applies to binomial expressions. And binomial expressions are when you have in parentheses 2 things added together. And that is something that you will be seeing when you factor by grouping. So it's important to kind of understand what those are as well. But you're basically just looking for the smallest exponent. So I've got 3 options here. So we'll start with x cubed and x to the 5th. So we've got 2 expressions, x cubed, x to the 5th. The greatest common factor is the smallest exponent, as long as they both have the same, they have to have the same letter and then the smallest exponent. So that's going to be x to the 3rd. So you're just like, okay, they both have x. What's the smallest exponent on x? 3. That's your answer. So it's like you don't have to do any work there at all. You're just looking, what do they have in common? What's the smallest exponent? So the next one we've got, these are binomial factors right here. Or binomial expressions, I should say. Because they are things in parentheses with 2 things added. So, but they both have exponents. So you're looking for, do the things in parentheses match? They do. And then the GCF has the smallest exponent out of the 2 choices. So we've got an exponent of 3, exponent of 2. 2 is the smallest. So our GCF is in parentheses x plus 3 squared. So it's what's in common and then the smallest exponent. So on the right, we've got x, y, and then y squared. So first you go letter by letter. So x is not in common. So x is not going to be in the GCF. So not in common. So that's not a greatest common factor because it's not in both of them, but they both have a y. So we've got a y without an exponent and then a y with a 2. So without an exponent, that's considered a 1 exponent, and 1 is smaller than 2. So your GCF is a single y. So no exponent compared to like an exponent of 2, no exponent is smaller. So that is your greatest common factor. Okay. So let's try to combine these ideas now, because the variable is pretty straightforward. So we're looking for the greatest common factor, and we're combining numbers and variables. So you've got two different rules going on. The rule for variables is different from the rule for the numbers. So you just want to keep that in mind. You can treat them this, if you do prime factorization, the rule is basically the same. But it's just a lot harder for people to kind of see that. So we'll start with the left, 12 and 16. So I always start with the numbers first when I'm finding my GCF. So we're looking for the largest number that divides into 12 and divides into 16. So you can do that mentally and get 4. So 4 is the largest number that divides into 12 and 16. But I'm going to actually do our divisor list just so you can see that. So 12 is 1 times 12, 2 times 6, 3 times 4. 16 is 1 times 16, 2 times 8, and 4 times 4. So you can see that 4 is the largest number they have in common. So first, between the numbers, our greatest common factor is 4. Then you move to the variables and you just go letter by letter. So we look at W. We've got an exponent of 3 and an exponent of 2. So 2 is a smaller exponent, so we're going to have a W second to the second, W squared. Then our next variable is Z. We've got a Z and a Z. If it's the same thing, then that's in common. They both have a Z. So that's part of your greatest common factor. So overall, the greatest common factor is 4W squared Z. So you just work piece by piece by piece. Numbers, and then look at your variables and just go each variable basically in alphabetical order. So in the middle here, we've got 15R squared S squared T to the 5th, and then 5R cubed S to the 4th T cubed. So with the numbers 15 and 5, the largest number I can divide out of both of those is 5. So I can divide 5 out of 5 and 5 out of 15. So that's going to be a part of my GCF. Then we're going to look at R. So our exponents on the R's are 2 and 3. So the smallest is 2. And then we go to the next letter, which is S. We have exponents of 2 and 4. 2 is smaller, so S is going to have a 2. And then you go to the next letter, which is T. And we've got a 5 and a 3. 3 is smaller. So you're going to have a 3 as part of your exponent there. And so your overall greatest common factor is 5R squared S squared T cubed. Now the third example here, we've got a negative. So we've got a negative 2W x cubed y, and then a 4xyz. If one of the numbers is negative, we usually have a negative in our greatest common factor. And this is because it makes it easier for us when we actually do factoring. So I'm going to just kind of make that rule here. If one of the numbers is 1 or more, because they could both be negative. So if 1 or more of the numbers is negative, so is the GCF. And that just makes things easier for us later on. So I'm going to just put a negative sign right there because I know I'm going to have a negative. And then I focus on the numbers 2 and 4. So the biggest number I can divide is 2. 2 divided by 2 and 4 divided by 2. I can do that mentally. I'm not even going to bother showing work there. Then W. So I have a W in one, but not the other. So W is not in my greatest common factor because it's not in common. They both don't have it. Then we go with X. So I've got an X cubed and an X. So just a regular X is smaller than an X cubed. So that's going to be in my GCF. Then I've got Y. I've got a Y in both of these, so that's in common. And then a Z. So there's a Z in the second expression, but not in the first. So that's not in common, so it's not going to be part of the greatest common factor. So your greatest common factor is -2xy. Okay, so I've got 3 more here, and these are using the binomial expression part. And I'm putting these in here because this is something that you'll see when you start factoring by grouping. So it's good to get some practice here on determining what is the greatest common factor. So we will start with the left. We have 2c cubed, and then in parentheses, 3c minus 5. Then we have 4c, and then in parentheses, 3c minus 5 to the 5th. So we focus on the numbers 2 and 4. The largest number I can divide out of both of those is 2. Then we look at just the c's by themselves. We've got the c cubed and the c. So just a plain c, that's a smaller exponent than a c cubed. So I'm going to write down c. Then you look at your binomial parts, the things that are in parentheses. So you treat those together. So we've got a 3c minus 5 without an exponent. And then we have a 3c minus 5 with an exponent. And it's an exponent of 5. So no exponent means there's fewer of them than having an exponent. So we're going to have 3c minus 5. And you don't need to multiply that out. You can just write it like this because the greatest common factor is a factor. It's something multiplied together. So you don't multiply it out, you just kind of write it there, and you're pulling from each number the biggest thing that you can kind of divide out. So if we move to the middle, we've got a 3 in front of a 2a minus b, and then nothing in front of a 2a minus b. So you have a number, but then you have something without a number. So there's nothing in common there to really divide out. It would be just like a 1 in front of there. And I can't, like, I can divide one of them by a 3, but not the other one. So then you're only focusing on the 2a minus b, which they both have. They don't have any exponents on it. So it's just a 2a minus b they have in common. So that's what your greatest common factor is. And it's in parentheses. It's 2a minus b. And then on the right, we've got a negative, and then in parentheses, x minus 5 to the third. And then we've got a 2, and in parentheses, x plus 5 squared. So whenever you see a negative, that's part of your GCF. I'm just going to put the negative sign there. I've got no number, no coefficient in my first expression. It's just a negative out there. And then I've got a 2. So I don't have a number in common because there's nothing I can divide out. If there's no number there, there's nothing to really remove. So I just have this negative. So then you look at what's in parentheses. I've got an x minus 5 and an x plus 5. They need to match in order for them to be in common. So one of these has an x minus 5, but the other one doesn't. The other one has an x plus 5, which is not in common. So even the binomial parts are not in common here. So the only thing that we have here is a minus that I've written down. So a minus isn't really anything. So we make it a -1. So the greatest common factor is -1, because the only thing that we could ever divide out here is a -1. Nothing else is in common. Sometimes your greatest common factor is 1. Sometimes there is none. And so it's important to know that that is possible. I wanted to write that in a different color. So sometimes there is nothing in common. So your GCF is just 1. So if we didn't have a negative in front of the x minus 5 cubed, our GCF would just be 1. There would be nothing in common. And if there's nothing in common, you just make it 1. But we had a negative, so we can factor out a negative, and so our GCF is a -1. But it's completely possible to have nothing in common, and you just use 1 as your GCF. And if it is 1, that generally means that you're not factoring anything out, because there's nothing in common to factor out. And the process is factoring is dividing things out. So just something to be aware of, that sometimes there is nothing in common. So that's all. Those are all the examples that I have. That is how you find the greatest common factor. Your next step from here would be to actually factor it out or divide it out. And so that is another video that I have that you can watch on how to actually divide it out once you know what it is. And once you know how to divide it out, then you have a good basis for factoring and being able to do everything else for this week. And factoring is so important. If you have to go on to college algebra, you're going to want to get really good at factoring, because you're going to factor a lot in college algebra. And to get good at factoring, you need to know your multiplication and division. So if you need to do flashcards for that, that is the best thing to do to get better at it. Because if you can do that in your head, it's faster than actually using a calculator to try to figure out all of your numbers. Because your goal is to basically have all of your pairings memorized, so you know instantly what the largest number you can divide out is. So if you can do that instantly, like in a second, that's much faster than going through your calculator, and it will save you a lot of time. So that's why it was so important to, the question about mental math in the start of the class, very important.